welcome you all to session 8 of the chapter Ray Optics. This session will be on prisms. First of all, let us understand what actually a prism is. A prism is an optical medium. A prism is an optical medium. It is a medium through which light passes. Right? A prism is an optical medium bounded by three rectangular faces and two parallel triangular faces. Okay, it is an optical medium bounded by three rectangular faces and two parallel triangular faces. This kind of optical medium is called as a prism. Okay, let us check it out how actually the prism looks like. Right? Okay, let me tell you, it looks like this now here. It has three rectangular faces. Right? Let me take like this. This is the prism. Right? It has three rectangular faces. One is backside and the other two faces are like this. Right? It is like this. So one rectangular face, two rectangular face and backside, three rectangular face and two parallel triangular faces. Right? So this kind of optical medium is called as a prism. So a prism is bounded by five faces, three rectangular faces and two parallel triangular faces. Right? Okay. Now let us check it out how actually refraction takes place in prism here. Right? To understand that, let us take the cross section of the prism. Let me call it as principal section of the prism. Okay. Let me cut this prism so that you get this surface, and let us understand how actually the refraction takes place by this prism now. Okay. Let me name this prism as A, B and C. Okay. If I am taking cross section, if I am taking principal section, I will be getting a face like this. A, B and C. Let us check it out how actually the refraction takes place in here, right? Okay, if a ray of light is incidenting at this space, let me call this is an incident ray. Okay, where actually is the normal? Normal is a line which is drawn at the point of incidence. Since it is a plane surface, we need to take a perpendicular line, right? This line is called as a normal. Now, the ray of light enters from air to glass. It is moving from rarer medium to denser medium. So what happens if a ray of light moves from rarer medium to denser medium? It bends towards the normal, right? If at all this prism was not there, then the ray would have been gone like this, right? If the prism was not there, ray would have been gone like this. Since there is a prism, it bends because it is moving from one medium to another medium, and it is moving from rarer medium to denser medium, so it bends towards the normal. Right? So there can be two types of bending, away from the normal and towards the normal, and it bends towards the normal when it moves from rarer medium to denser medium, from air to glass. Yes, it bends towards the normal. And this ray, let me call it as refracted ray. Right? Again, at this point, I will be taking normal so that we can just study how actually the ray moves now here, right? So at this point, if I am taking perpendicular line, this will be the normal. Now, the ray of light is moving from glass to air. It is moving from denser medium to rarer medium. So, if a ray of light moves from denser medium to rarer medium, it moves away from the normal, right? Okay, let us check it out. This ray moves away from the normal, right? It moves away from the normal, and let me call this ray as emergent ray. Okay, so let me take like this. This is P, this is Q, and let me call it as R, and let me call it as S. Okay, what is PQ? PQ is incident ray. PQ is incident ray. What is QR? QR is refracted ray. Let me call it as QR as refracted ray and RS as emergent ray. So when we speak about refraction through prism, we get three kind of ray. One is incident ray, one is refracted ray, and another one is emergent ray. Right? Okay. And also, whenever I speak about the prism, I speak about its angle. Let me tell you what actually the angle of prism is. Okay. First of all, let us understand what is angle of prism. It is the angle between It is angle between two refracting faces. Angle between two refracting faces is called angle of prism. It is called as angle of prism. Do you understand what is angle of prism? And it is denoted by A. It is the angle between two refracting faces, right? For example, if there is a prism like this, right? If a ray of light enters like this, right? It refracts and moves like this. Then these two are refracting faces, and let me call it as angle of prism. Right. So if ray of light enters here and moves this side, this will become angle of prism. Now the ray of light enters at this surface and exits at this surface, then these two will become refracting faces. And the angle between these two, this is the angle A, and the angle between two refracting faces is called as angle of prism. Okay. Now in this diagram, what is angle of prism? Let me call angle A as angle of prism, right? So what is angle of prism? Angle of prism is angle between two refracting faces, right? Okay, if I am taking, this is incident ray, this is emergent ray, these two will become refracting faces, and this angle is called as angle of prism, right? Okay, now let me speak about another angle, that is angle of deviation, right? Okay, now if at all the prism was not there, this ray would have gone like this. As there is a prism in between, this incident ray deviated in this direction. Okay, let us check it out how much it deviated, right? So it deviated like this. So this angle which is formed here, this angle is called as angle of deviation, and it is denoted by delta, right? So what is angle of deviation? It is the angle by which the incident ray is deviated after refracting by prism, right? Or we can also define it like this. It is angle between, okay, it is angle between, okay, which is this ray? This is incident ray, which is say emergent ray. I have extended like this, right? Okay, shall I say like this? Angle between incident ray, angle between incident ray and emergent ray. Emergent ray is called angle of deviation, is called angle of deviation, and we denote it by delta. Do remember, whenever I speak about the prism, I speak about two angles. One is angle of prism and another one is angle of deviation, right? Okay, how much it is deviated, right? So the angle between incident ray and emergent ray, so this much angle it is deviated, so this angle is called as angle of deviation. So in the diagram, let me call delta as angle of deviation. So A is angle of prism and delta is angle of deviation. So just it is an introduction about prism and how actually the refraction takes place. So what are the consequences? So let us understand that under the side heading refraction by prism. Now let us take a derivation of refractive index of material of prism in terms of angle of prism and angle of minimum deviation. Okay, that is the derivation which I will be deriving now under the side heading refraction by prism. Let us take a prism and let us check it out how refraction takes place. Okay, now let me take the principal section of prism. Okay, this is the principal section of the prism, cross section of the prism. Let me take like that. This is the cross section of the prism. Let me name it as A, B, and this is C, right? Okay, now this is the angle of incidence. Okay, if at all prism was not there, then the ray would have gone like this. At this point, I need to take normal perpendicular line, and this is the normal. And what is this? This is angle of incidence. What is angle of incidence? Let me take it as I. Now, as the ray is moving from rarer to denser medium, it bends towards the normal. Let me take like this, it bends towards the normal. And again, at this point, I will be taking a normal now here. Okay, now I will be taking a normal. The angle between the normal and the refracted ray, let me call it as angle of refraction Since there are two angles of refraction, let me take it as R1 here, and let me take R2 here, right? Then as the ray is moving from denser medium to rarer medium, it moves away from the normal. Okay, let me take like this. This is incident ray, angle of incidence. Refracted ray, these are angle of refraction. Let me take like that. This is emergent ray, the angle between normal and emergent ray. Let me take it as angle of emergence, and let me take it as E now here, right? This is angle of emergence. As we have already studied about incident ray, refracted ray and emergent ray, we come across two angles in a prism. One is angle of prism and another one is angle of deviation. Okay, what is angle of prism? As these are the two refracting surfaces, angle A becomes angle of prism, right? And this is the incident ray and this is the emergent ray. If I extend this emergent ray, it will meet at this point. If prism was not there, the incident ray, it would have moved like this now here. Now it deviates, and this angle is called as angle of deviation, and let me take it as delta. Delta is the angle of deviation, right? Okay, this is angle of prism and this is angle of deviation. Let me name it as P, Q, R, and let me take it as S. Let us start with the derivation now. Here, what is ABC? ABC is principal section of prism. Let me tell you what we have drawn here. AB is principal section of prism. Okay, what is PQ? PQ is incident ray. PQ is incident ray. What is QR? QR is refracted ray. Let me call it as it is a refracted ray. What is RS? RS is emergent ray. This is emergent ray. This angle, let me call it as I, that is angle of incidence, right? Okay, what is I now here? I is angle of incidence, right? So what are these R1 and R2? R1 and R2, these are angle of refraction. Let me call it as these are angle of refraction. And what is E? E is angle of emergence. Let me take like this. E is angle of emergence. What is angle A? Angle A is angle of prism, right? Angle between two refracting surfaces, we call it as angle of prism, and this is A, that is angle of prism. Then what is delta here? Delta is angle of deviation, right? So this is the angle between incident ray and emergent ray, and that delta is angle of deviation, right? Okay, now we have seen what actually we have drawn here, right? Okay, let me name this as let me take it as M and let me call it as N. Now what I will be doing, just I will be calculating about refractive index of the material of prism now here, right? Okay, let us start with the mathematical equations now here. In quadrilateral AQNR, okay, just observe the quadrilateral AQNR. Okay, in quadrilateral AQNR, just observe the quadrilateral AQNR. Okay, see here, if you observe the quadrilateral AQNR, it looks like this. This is AQN and this is R now here, right? Okay, this is angle A, this is Q, and this is N, and this is what we say here, R. Come on, tell me, what is this angle? This angle is 90 degree. Yes. Why it is 90 degree? Because which is this line? This is normal, right? So this angle is how much now here? 90 degree. What is this angle? That is also, this is prism and this is normal. And what is this angle now here? That is also what we say now here? 90 degrees. right? We have these two angles 90 degrees. In this quadrilateral, we know the sum of all the angles in a quadrilateral is equal to 360 degrees. Already we have 90 plus 90, that is 180 degree. Okay, how much angle is remaining now here? 180. Shall I say like this? Angle A plus angle, which is the angle remaining now here? QNR, which is that now here? Here, QNR. QNR will be is equal to how much now here? 180 degrees, right? Angle A plus angle QNR is equal to 180 degrees because the sum of other two sides, this is equal to 180 degrees. This is 90, this is 90. This together is equal to 180 degree. What is the angle remaining? 180. So angle A plus angle QNR must be equal to 180 degree. Okay. So this is the equation number 1. Okay. Just understand how did I get this equation here, right? Angle A plus QNR is equal to 180 degrees. Right? Okay. Now let me go on to the next one here, right? In a triangle QNR. Okay, let me take in a triangle QNR. Where is that now here? Here. QNR. This is the triangle which I am taking here, right? Do you understand? So this is the triangle which I am considering, right? This is Q and this is what we say here? R. Which is this angle? This is R1. What is this angle now here? It is R2. Okay. In triangle QNR, we know that the sum of angles in a triangle is equal to 180 degree. Okay, shall I use that concept here? That is R1 plus R2, right? R1 plus R2 plus angle QNR, which is this angle QNR is equal to how much now here? 180 degree. Let me take it as equation number 2, right? Okay, so this is the triangle which I have considered, QNR, and R1 plus R2 plus QNR is equal to 180 degree, right? Now we shall compare these two equations. Comparing equations 1 and 2, what do you get? Here also 180 degree, 180 degree, angle QNR, angle QNR. Shall I say like this? A is equal to, must be equal to what? R1 plus R2, and this is equation number 3, right? We have arrived at one equation, that is A is equal to R1 plus R2, means angle of prism will be equal to the sum of angle of refractions, right? So A is equal to R1 and R2. Let me take it as equation number 3 now here, right? I will be making use of this equation number 3 in the later section now, right? So we got A is equal to R1 plus R2. Now I'll be going with the next concept. Okay, keeping this in mind, let me take one triangle. Okay, shall I take this triangle? Just observe here, QMR. Just you observe, I am taking the triangle QMR. Okay, after getting these equations, let me go ahead. In triangle, which triangle shall I take? QMR. Just you observe QMR. So I will be drawing here. This is M and this is R. This is M and this is Q and this is R. QMR. This is the triangle and this is extension part, and this angle is what we say here? Delta. Right? Okay, just you observe this and this. Right? Both are similar. This is delta. Here also it is delta. Right? So QMR in this triangle, what is this delta angle? Shall I call it as exterior angle? We know what is the formula for exterior angle, right? Exterior angle will always be equal to sum of interior opposite angles. Interior opposite angles. We know that always exterior angle is equal to sum of interior opposite angles. So if shall I call this is exterior angle, this is interior angle, sum of interior opposite angles means Q angle plus R angle. Shall I say like this? Okay, exterior angle equal to sum of interior opposite angles, right? What is exterior angle in this case? QMR. Exterior angle is delta is equal to sum of interior opposite angles. So interior, these are opposite angles, interior opposite angles. So which is this angle? MQR. Okay, shall I say like this? MQR plus angle. What is that? MRQ. What is that now here? MRQ. Right? So exterior angle equal to sum of interior opposite angles. Okay, delta is equal to mqr plus mrq. Okay, next what we need to understand here is what is this angle? What is mqr? Just observe in the ray diagram here. What is mqr? Here it is there, mqr. Okay, just observe one thing here. If I am considering like this is the side now here. Let me take like this. This is the side now here, and this is the incident. And if I am taking like this angle here. Okay, now this is like this. Okay, I want q, right? We want mqr. This is the point m, and what is this now here? This is r, right? What is mqr? Come on, tell me. What is this angle? This angle is angle of incidence. Okay, if this angle is angle of incidence, what is this angle? Come on, tell me. What is this angle? That is also angle of incidence, because if I am taking like this, these two angles will be equal, right? So vertically opposite angles, we call it as vertically opposite angles. So what is this angle? This angle is angle of incidence. But we know that this angle is r1, and we know that this angle is what now here? r1. So what shall I take? What is mqr? What is mqr? mqr is I minus r1, right? So if I am taking I minus r1, I will be getting mqr. So this whole is I, and we need to subtract r1. So what is mqr? mqr. Shall I take like this? mqr is I minus, what shall I take now here? r1 plus. This is I minus r1. Do you understand? This whole is I, right? And we need to subtract this r1 so that we get this angle, right? So that is I minus 1. Come on, tell me now, what is mrq? Where is m? mrq. I want this angle. Observe here. I want this angle. What is this angle? We know if it is angle of emergence, this whole is also angle of emergence, right? So that is E minus, what shall I take now here? R2. In the similar manner as we have taken here, this whole is E minus R2. So what shall I take now here? E minus R2, right? Simple. If there are two triangle here, if this is R2 and this is angle of emergence, this whole is angle of emergence, and we want this angle, so E minus R2, what I have taken here, right? Vertically opposite angles. Okay, now let me go ahead now here. So let me simplify that. We got equation 3. Let me write here equation 3, that is R1 plus R2. This is equation 3 now. Okay, so I need some space for the calculation. Let me write here. Okay, what do I get here? That is equal to I minus R1 plus E minus R2. Shall I take like this? Right? What do I get? Shall I bring I and E one side? So minus of R1 minus R2. Shall I simplify this? I plus E minus, if I take into the bracket, we will be getting R1 plus R2. Right? Okay. So here I keep minus outside. What do I get here? R1 plus R2. But from equation 3, we know what is R1 plus R2. That is equal to A. So shall I substitute here? That is delta is equal to I plus E minus what we say now here? A. Right? So this is equation number 4. Right? So delta is equal to I plus E minus A. That is equation number 4 we get. Okay. Before I continue with that, let me write that result also here. Delta is equal to I plus E minus A, and that is equation number 4. Right? So we have used a concept of exterior angle. Exterior angle is equal to sum of interior opposite angles. Right? Okay. We got 4 equations. Right? Now let me go ahead now here. Right? So actually we are deriving refractive index of a material of prism. So what is the formula for refractive index? Refractive index n is equal to sin I divided by sin R. In equation 3 we have R, in equation 4 we have I. So I will be using these 2 equations now here, right? Okay. Now let us consider a special case. That is at minimum deviation. At minimum deviation. What is the meaning of minimum deviation? Let us check it out. Okay. First of all, the angle of deviation depends upon angle of incidence. Okay. let us take a graph now here, right? So if I'm considering a graph, what do I get? So experimentally it was observed that as angle of incidence increases, angle of deviation, how it varies, let us check it out. Let me take, this is angle of deviation, and let me take, this is angle of what we say here, incidence. Along x-axis, let me take angle of incidence. Along y-axis, let me take angle of deviation. As angle of incidence increases, the graph you will be getting like this. As angle of increases, angle of deviation decreases, and it moves like this. This is the graph what we get, and we get this experimentally. It was observed that as angle of incidence increases, angle of deviation first decreases, and after a particular angle, and again it increases. At a one single angle of incidence, the deviation is minimum. Okay, shall I say like this? This is minimum. Okay, this angle, let me call it as angle of minimum deviation, right? Okay, see here, as angle of incidence increases, angle of deviation decreases, right? And again, after certain angle, it again increases. At a particular angle of incidence, deviation is minimum, and that angle of deviation is called as angle of minimum deviation. And this angle of minimum deviation takes place when angle of incidence is equal to angle of what we say here, emergence. Right? Okay, this we will be verifying experimentally. When you come to the lab, you will be having this experiment. Right? We will be giving prism to you, and you will be wearing angle of incidence, and you will be checking it out how what happens to the angle of deviation, and you will be getting with this graph now here. Right? At a single angle of incidence, angle of deviation is minimum. Right? Okay, and at this angle of incidence, the angle of deviation is minimum, and that angle of deviation is called as angle of minimum deviation, and we denote it by dm. What is delta? Angle of deviation. What is the dm? Angle of minimum deviation. And when does the angle of minimum deviation takes place? Angle of minimum deviation takes place when angle of incidence will be equal to angle of emergence. Okay, just check it out. If this angle will be equal to angle of emergence, then we will be arriving at a condition called minimum deviation. Right? Okay, now let us check it out. What happens at angle minimum deviation? D delta is equal to, what do you get here? Dm. Right? So delta will become dm. And what is the condition that here? Angle of incidence will be equal to what we say here? Angle of emergence. Right? Okay, check it out. If angle of incidence is equal to angle of emergence, then these two angles will be also equal. Right? So that implies R1 is equal to what we say here? R2. Do remember, if these two angles are equal, and these two angles will be equal, right? That implies R1 and R2 are both equal, and let me take it as simply R, right? As they are equal, we will be getting with R. So you need to understand this. When you are deriving this derivation, this graph is must. You need to draw this graph, right? This graph carries 1 mark. Right? You need to draw the graph and write the conditions beside now here, right? At minimum deviation, delta is equal to delta dm. So what are the conditions? Angle of incidence must be equal to angle of emergence. What happens if these two will be equal? These two again becomes equal here. R1 is equal to R2, and that we will be getting with R now here. Now, I will be applying these conditions in these two equations, and I will be arriving at that angle of incidence and angle of refraction. Then I will be using Snell's law, and we will be arriving at that refractive index of the prism here. Okay, now let us check it out from equation 2. Okay, let us check it out. I will be writing both the equations here itself. From equation 2, what is equation 2? A is equal to R1 plus R2. This is equation 2. Okay, substitute this condition here, right? So that is equal to R1 is equal to R2 is equal to R. Shall I take R plus R, because both are equal now here, right? So what you will be getting? That is 2R. So what do you get? R is equal to A divided by 2. Do you remember? We arrived at angle of refraction, that is R is equal to A divided by 2, right? So we got angle of refraction. What do we need next? We need angle of incidence to use Snell's law. Okay, let us go with equation number 3. From equation 3. Okay, sorry, this is equation 3 which I had already taken. This is equation 3 now here. Now I'll be using equation number 4. Okay. Now, what is equation number 4? That is delta is equal to I plus E. What do we get now here? Minus A. Substitute these conditions now here, right? Okay, in place of delta, what shall I substitute? Dm, that is angle of minimum deviation, right? These two will be equal. So shall I say like this? I plus I, because angle of incidence equal to angle of emergence. What do you get here? Minus A. That is equal to 2I minus A. Shall I bring A this side? What do you get? A plus dm is equal to, what do you get now here? 2I. Then what is I equal to? A plus dm divided by 2. Right? So A plus dm divided by 2, and this is the angle of incidence. Okay, see here. By equation 3 we got angle of refraction, by equation 4 we got angle of incidence by using this condition, that is at minimum deviation, right? So A plus dm divided by 2. What is A here? That is angle of prism. What is dm? That is angle of minimum deviation, that is dm now here, right? So this is the condition, at minimum deviation. So with that condition we will be arriving at angle of incidence and angle of refraction. Now I'll be using Snell's law, right? Okay. Now we will be arriving at Snell's law now here. Okay. We will be using Snell's law and calculates refractive index of material of prism. Okay. Now from Snell's law, using Snell's law, right? Refractive index of material of prism, refractive index of material of prism. So what is the formula? N is equal to sin I divided by sin R, right? So that is equal to, N is equal to sin of, what is I? We got, what is the I now here? A plus dm divided by 2 whole divided by sin R. Sin R, what is R now here? A divided by 2, and this is the equation, right? So this is the expression for refractive index of material of prism, right? If the prism is made up of glass, then what is the refractive index of glass? How to calculate it? Okay, use this formula, right? So this is the refractive index of prism formula in terms of A and dm, in terms of angle of prism and angle of minimum deviation, right? So this is a 5 marks derivation here, right? So derive the expression for refractive index of prism in terms of angle of minimum deviation and angle of prism, and we got with this expression N is equal to sin of A plus dm divided by 2 divided by sin of A divided by 2, right? Okay. Now let us take one note point. Let us take with one concept called thin prism. As we have already taken about thin lens, there is one concept called thin prism. When a prism is called as thin prism, right? A prism whose angle of prism is very small. Here, a prism whose angle of prism is very small. Small means it will be lesser than or equal to 10 degrees, right? If angle of prism is less than 10 degrees, then that kind of prism is called as thin prism, right? Okay. A prism whose angle of prism is small is called thin prism. It is called as a thin prism, right? A prism whose angle of prism is very small is called thin prism, right? Okay. Now let us check it out. What happens to this formula for thin prism? For thin prism, do you understand? What is thin prism? Angle of prism is small. If angle of prism is small, definitely angle of minimum deviation, let me take like this, dm, so R, what we say here? Small, right? Do you understand? If angle of prism is small, angle of minimum deviation is also small, right? For example, what is thin prism? Let me take like this. So this is thin prism, right? Angle is small. If angle is small, what happens? Let us check it out. It moves like this and it comes outside, right? So this angle, if this is small, this dm is also small, right? So if angle of prism is small, angle of minimum deviation, that is also is small. Okay, let us take like this. For thin prism, A and dm are small. Okay, then what happens? This formula, n is equal to, right? We know that for small angles, we know that for small angles, sine theta is nearly equal to what we say here? Theta, right? We know this. We can substitute only theta if angle is small. If angle is small, in place of sine theta, you can replace it by theta. So here I will not be using sine of a plus dm by 2. Instead of this, I will be taking a plus dm divided by 2, right? Why I have taken like this? Because these two angles are small here, right? Okay. Now, sine of a by 2, instead of that, shall I take now here? A divided by 2, right? Because a is small, right? So this 2 will get cancelled. What do you get now here? A plus dm divided by a, that is n equal to. Okay. Shall I take this side? N into a is equal to a plus what we say now here? Dm. Right? What do you get about the angle of minimum deviation? Dm is equal to Na. If you take this side, it will be minus a. Okay. Then what will be? Dm is equal to, what is common here? A is common. What is remaining inside? N minus 1. And this is the formula for angle of minimum deviation for thin prism, right? What is the expression for angle of minimum deviation of thin prism? That is dm is equal to a into the bracket n minus 1. It depends upon angle of prism and it also depends upon refractive index. Angle of minimum deviation does not depend upon angle of incidence. It depends upon only angle of prism and refractive index, and the formula is dm is equal to a into bracket n minus 1, and this is the expression for angle of minimum deviation, that too for which prism? For thin prism, right? So this is the expression of refractive index of prism, and we have taken thin prism as one of the case, and we calculated what is the angle of minimum deviation.